The next topic we have to study is Ohm's law or deduction of Ohm's law. So far we studied about drift velocity and electric current. Drift velocity equation we derived minus E by m into tau. The electric current equation also we derived I is equal to NAEVD. So I is equal to NAEVD, that I am going to take equation number 1. Drift velocity Vd is equal to minus EE by m into tau, that I am going to take equation number 2. Now what is the next step? I am going to substitute equation number 2 in equation number 1. When I substitute equation number 2 in equation number 1, I will be getting I is equal to NAE into minus EE by m into tau. So this can be written as minus of NAE square E by m into tau. Put as equation number 3. Now one more thing I want to substitute in equation number 3, that is for electric field across ends of the conductor. Electric field across ends of the conductor E is equal to minus V by L. Put as equation number 4. If I am substituting 4 in 3, I will be getting the equation I is equal to NAE square divided by m into V by L into tau. Because minus and minus cancels each other, therefore there will be no minus in this equation. So I am grouping this equation by just keeping V only outside and all other quantities inside the brackets. When I keep V, the voltage across the conductor only outside and all other quantity inside the bracket, I will be getting I is equal to N E square A tau by ml into the voltage V. Now what is this N? Number density of free electrons in the conductor. Number density of free electron in a given conductor is a constant. And what is E? Charge of electron. Charge of electron is a constant. And what is A? Area of cross section of the conductor. For a given conductor it is a constant. And what is M? Mass of electron. Mass of electron is a constant. What is L? Length of the conductor. Length of the conductor is also constant for a given conductor. So each and every term inside the bracket is a constant, and that can be replaced by a single constant, and that single constant is nothing but 1 by r. 1 by r is equal to NE square A tau by ml, and therefore r is equal to ml divided by NE square A tau. And this particular proportionality constant is called electrical resistance. We already studied this particular thing in 10th standard. Since I is equal to 1 by r times V, I can write V is equal to Ri, or V proportional to I. This is what Ohm's law. Ohm's law gives the relation between the potential difference across ends of the conductor and the resulting current. Ohm's law can be defined as at a constant temperature. At a constant temperature, the potential difference across the ends of the conductor is directly proportional to current. This is what the definition of Ohm's law. Now, there is a clause given when we define Ohm's law at a constant temperature. Why should the temperature remains constant? And that explanation I can give according to this equation. Ohm's law proportionality, linear proportionality is there only if R remains a constant. R should be an absolute constant. Now let us discuss this particular equation. From this equation it is very clear that R proportional to 1 by tau. What is meant by tau? The relaxation time. Average time interval between two successive collision. That is what tau. Now just think about increase in the temperature. As the temperature increases, what happens to free electrons? The free electron gains more and more energy. As the free electron gain more and more energy, their motion become energetic. When their motion become energetic, collision, frequency of the collision increases. When frequency of collision increases or collision become frequent, average time interval between collision decreases. So when the temperature increases, average time interval between collision or relaxation time decreases. Since R proportional to 1 by tau, when relaxation time decreases, resistance increases. When resistance increases, this proportionality, linear proportionality is no longer there. That is why we are putting a clause along with the Ohm's law definition at constant temperature, because R remains constant only if temperature remains constant. Now, the graph between voltage and current is a straight line. Now you can see the graph between voltage and current. I am taking voltage along x-axis and current along y-axis. The graph between voltage and current is a straight line because R is a constant. Now what is the significance of slope of the graph? Slope of the graph means perpendicular by base. Perpendicular is nothing but I and a base is V. So I by V is nothing but inverse of the resistance. Slope of any VI graph gives the inverse of resistance. Now sometimes I may control current and I will measure the potential difference across any 2 points in the conductor. By changing the current, I am going to measure the potential difference across a resistor or any other appliances. At that time I am controlling current. So the physical quantity which I am controlled is taken along x-axis because it is independent quantity. The physical quantity which varies with the controlling quantity is taken in the y-axis because it is dependent quantity. If I am changing the current, current should be taken along x-axis, voltage should be taken along y-axis. At that time also the graph will be a straight line, but the slope of the graph will be directly V by I. Directly it will give the resistance. Anyway, the slope of a voltage current graph gives the resistance. Okay, so if I is in the x-axis and V is in the y-axis, more the slope, more will be the resistance. Now another thing I want to discuss is electrical resistance. So we already studied in smaller classes electrical resistance. Equation for electrical resistance according to Ohm's law, R is equal to V by I. So resistance is the ratio of the voltage given to the resulting current. Okay, it is a ratio of the voltage given to the resulting current. If the current is less for a given voltage, that means resistance is more. On the other hand, if the current is more for a given voltage, that means resistance is less. Resistance is nothing but opposition offered by the conductor for the flow of current. What is the cause of this opposition? The collision of the electron with the neighboring atoms, ions and neighboring electron is the cause of opposition. Okay, so the definition of resistance is R is equal to V by I. From this equation, what will be the unit? V is measured in volt, I is measured in ampere. Therefore, unit of resistance will be volt divided by ampere, and that also termed as ohm, OHM, denoted by this particular symbol. Now the next question arises, what is 1 ohm? 1 ohm is nothing but 1 volt divided by 1 ampere. If 1 volt potential difference across the ends of the conductor produces 1 ampere current, then the resistance of that conductor is said to be 1 ohm. Now the equation which we derived for resistance is the basic equation for electrical resistance, an important equation for electrical resistance, and that is given by R is equal to ml divided by N E square A tau. Now look at this particular equation. This is the minute equation for electrical resistance. So in this one, m is a constant. What is m? Mass of the electron, that is a constant. E is also constant. What is E? Charge of electron, that is a constant. Then we can discuss about the factors affecting electrical resistance. This equation directly gives the factors affecting electrical resistance. The first factor is length of the conductor, R proportional to L. As the length of the conductor increases, electrical resistance increases. More length of the conductor means more distance the electron need to travel and more will be the collision it encounter. And a second factor is R proportional to 1 by A. R proportional to 1 by A, area of cross section. If area of cross section increases, resistance decreases. Thick wire, resistance will be lesser because its area of cross section is more. Thin wire, resistance is more because its area of cross section is less. In the case of thin wire, the space available for the flow of electron is less, so there is chance of more collision. In the case of thick wire, the space available for the drifting of electron is more, there is a chance of less collision only comparatively, and that is why the resistance is less. And a third factor is nature of the material of the conductor. So you can see a factor like n, number density of free electron, and that particular factor is different for different conductor. So each conductor having a particular nature, the conductor of copper and aluminum of same length and same area will have different resistance. Why they are having different resistance? Because their nature is different. And the fourth one is the temperature. Temperature is not directly appearing in this equation, but relaxation time is appearing. From that equation, it is very clear that relaxation time and temperature, the resistance are inversely proportional, are proportional to 1 by tau. Now, I already explained in this video itself what happens as temperature increases. So here I have written that as temperature increases, electron gain more energy and their collision become frequent. As the collision becomes frequent, time interval between collision decreases. The time interval between collision is nothing but relaxation time. As the relaxation time decreases, electrical resistance increases. So that means as temperature increases, relaxation time decreases, electrical resistance increases. So these are the factors affecting electrical resistance. What is electrical resistance? Electrical resistance is the ability of a conductor to oppose the flow of electron, or it is the ratio of voltage given to the resulting current in the conductor.